Throughout your networking career, you're likely to see many topologies, many different networks with lots of different components. But what we see on screen is just a basic sample of some of the components that you're likely to see a lot. For example, routers and switches and clients and file servers. We've got links out to a remote network such as the internet. Let's spend just a few moments and zoom in on some of these different elements that we're likely to find in the network. For example, the end user is using some sort of a client. Maybe it's a desktop, maybe it's a laptop, maybe it's a smartphone or a tablet. But a client device is how the user interfaces with the network. And one resource that they might be trying to access on the network is a file server. A file server can be thought of as a computer that shares its hard drive with clients. And of course, depending on the network operating system running on the file server, there are different ways of setting up who has permission to access which files. But for the purpose of our discussion, let's just think about the job of a file server. The file server is going to make files available to our clients. And because all the clients are pointing to this same shared repository, one client can make an update, and that update is suddenly reflected when the next client downloads the file which was updated. But how do the file servers connect into the network? Well, typically, they're going to be connecting into the network by connecting to a switch. And a switch is referred to as a layer 2 device. We'll be talking about that later. A switch, specifically an Ethernet switch, can make forwarding decisions based on what it learns from the attached devices. You see, inside the file server, inside the client, there is a network interface card, an NIC or a NIC. Inside the Ethernet attached device, there is an address that is burned in physically to that card. It's called a MAC address, MAC. That's a media access control address. And the switch can learn which MAC addresses live off of which ports. And once it learns that information, it's going to see a frame destined for a particular destination, and it's going to say, well, I learned that that MAC address lives off of this port, so I'm going to forward that frame out of that port. And you also see on screen a router. A router is a layer 3 device, meaning that instead of making forwarding decisions based on things like MAC addresses, physical addresses, a router, it's going to make forwarding decisions based on logical addresses, networking addresses. We're going to have a big discussion later on about networking addresses and how they work. But for now, just understand that architecturally, as we think about a network, the end user is connecting into something like a switch, and switches can connect to other switches, switches can connect to routers. But as our network starts to scale, and we have different network addressing concerns, as we'll get into later, a router can give us that scalability. A router can also give us flexibility and allow us to connect to non-Ethernet devices, such as connecting out to the internet. And you also notice in the diagram that we have different media interconnecting our devices. We might have category 6 twisted pair cabling connecting our end user devices and our file servers into a switch. Maybe we have the same thing between a switch and a router. We could use fiber optics in some cases. We've got different wide area network links coming in from our service provider to get us out to the internet or some other remote network. And that's another topic that we'll be covering. What types of media are used to get us around the network? And now that we've had this brief introduction to some of the fundamental components in the network, we need to start thinking about how to classify networks. We can classify networks based on how geographically dispersed they are, or how they're interconnected. For example, on screen, this is a network that we're assuming is in a single building. Within the building, this network that we see is a LAN, an LAN, a local area network. But you see, there's a WAN, a WAN, a wide area network link that's connecting us off somewhere else.